Some students ask me a question like, when we do the CRC long division, why can't we convert it to decimal numbers and then do the decimal division and then convert the results back to binary? That's a very good question. To explain this question, we need to understand the original purpose of the CRC. So the inventor of CRC was originally trying to find a checking mechanism that could generate a totally different result even if one bit is altered. So apparently he was inspired by the modulo calculation, right? For example, if you use 3 as a divisor, then you can get 441 and 0 as a remainder. If the message has been altered, say here, you change 2 to 3, then the result will be 44 and the remainder will be 1. So it's right, we can check from the remainder to see whether the message has been altered or not. Similarly, for binary stream, if one bit has been altered, by doing this checksum, we will generate a totally different remainder. So that's the main purpose. In other words, as long as it can achieve this purpose, it doesn't matter you use the modular way or some other algorithm. So now let's check the CRC calculation and see whether it fulfills this purpose or not. First, let's review. For message 1001, 1010, okay, how to calculate the CRC remainder for a given generator, say 1101. First, we need to find the length of this divisor L. Now you see it's 4 digits, so we need to append L minus 1 zeros to the original message. So we need to append 3 zeros to the original message. This is because we want the remainder to be less than the divisor. And then we will perform the polynomial long division. So remember here, the so-called polynomial long division is not equal to the binary long division. A binary long division, for example, 110 over 101, okay, the result will be 1 left, right? Similarly, here, 110, if we convert it to decimal, is 6, and 101 is 5. If you use 6 to be divided by 5, we will generate the same result, right? However, by the CRC calculating rule, it's something like this, 101. Here we will do exclusive OR operation, which will be 1, 1. You see, that's not the same. So here, let's use CRC's way to calculate it. So here, 1, 1 will be 0, 1, 0, 0. Right, this is the XOR operation when we do the minus. Then we have 1. So we have another 1, it will be 1, 1, 0, 1. Which will be 1, 0, 0, and we give this 0 here. So we have another 1 will be 1 1 0 1, which is 1 0 1, and add this one here will be 1 0 1 1, and okay, another one will be 1 1 0 1. So it's 1 1 0, right? 1 1 0. Add a 0 here, 1 1 0 0. So here we get a 1 1 0 1, which will be 1, and add all this 3 0 here. So we need one more division, which will be 1 0 1. This will be the remainder for the CRC. Why is it like this? Why CRC doesn't use the ordinary division way? Because suppose this is the receiver, and you can imagine your message is just like a long strip, like the paper belt people used back to the beginning of the computer to come in and after calculation go out. So here your message is 1001, 1010. Suppose the receiver already chose the generator, which is 1101. So whenever there's 4 bits, okay, came into the receiver, it will start the CRC calculation, and then, for example, here, it will generate a result which is 100. Then the next bit came in, and it will keep running the CRC division. Actually, it's the XOR operation. Then the result this time will be 100 again, right? And the next will be 0. So it's 1101, right? So on and so forth. So now you can see why we didn't use the ordinary long division, because that requires borrow operation. When we learn mathematics, the first thing we learned is carry and borrow. For example, when you do a decimal operation, you need to borrow 1 from your previous digit. Similarly, for binary subtraction, you need to borrow 1 from your previous bits. Suppose the receiver is a very simple machine. If we use XOR, it will just simply do the bitwise calculation, right? It doesn't need to borrow from the previous bit. That means it doesn't need to remember the previous bit. So no memory is required, right? Now remember the original purpose for the CRC checksum? It doesn't matter we use XOR or the true division operation, as long as we can generate a totally different result. Here means a totally different remainder when we altered 1 bit of the original message, then we can use it. So for example here, if we still use this example, if we altered the message to be 111, so in binary division we will get 10, and in the CRC division we will get 10. So compared with the original message, the remainder 1 is changed from 01 to 10, 1 is changed from 11 to 10. So both generate a different result from the original one. And plus, the exclusive OR operation is a bitwise operation. It doesn't need to borrow from the previous bits. It doesn't need to remember the previous bits. It is more convenient and require less computing. So that's why we use this kind of division instead of the binary division.